Hey guys, how we doing? We are set for section 2
Yep.
of congruent triangles.
Congruent triangles.
This is a big chapter.
Yes, huge.
I can't remember necessarily what we said in video 1 here
Yeah.
for the section for the chapter, but this is probably this is the main chapter that makes this a college prep class.
Yep.
It is
Yep.
because this is what we don't do in pre-geometry. And this is the main thing and so this is one where you need to dig in, guys, and make sure you're understanding each step as we progress. So, okay, so we'll do our best to take it step by step for you and explain everything we can and hopefully make it clear. So section 4.2 is titled Applying Congruence and Triangles. And so this is really lining up the things that line up when we have two triangles congruent to each other. And I don't know how you explain it, but I always explain it where the triangles land on top of each other. And you got to be able to pick the pieces that line up when that landing happens.
And it's a big push that they're doing now in the new Common Core of getting kids to understand visually that exactly it, that you could just lay one on top of the other and what pieces are the same.
Yeah. So when we're talking about that, maybe think of an overhead projector, old school. Think about the pieces of plastic that you've seen teachers lay on top of an overhead projector. That would be it. We just lay pieces, lay one triangle that's on a piece of plastic on another triangle that's on another piece of plastic, and that they would land right on top of each other. However, you have to turn it, flip it, whatever, to where they land on top of each other and line up exactly. So let's see what we got here. Well, we've already
Review
talked
word
about
here.
congruent.
Yeah.
We
Yep.
talked about congruent, so we're just applying it to triangles. So they are the same size and shape triangles that we have. So they have the same size angles, and they have the same length of sides.
I think biggest thing difference now with congruent is we're moving from just a one-dimensional type thing to we're looking at a shape which is two-dimensional, and so congruent shapes is more the issue
Yeah,
now.
yeah, we're talking
know.
about more than one thing here.
Yeah, exactly.
More than one measurement.
Right.
Yeah.
Right.
Yeah, so corresponding parts. This is critical to understand, guys. Corresponding parts are that whole lining up thing, that if they land on top of each other, what angle in one triangle lands on what angle of the other triangle. What side of the one triangle lands on what side of the other triangle. That's the corresponding parts here. And so congruent angles and sides of the different triangles that line up.
Yep. I mean, if you think about transversals, we just came from this.
Mm-hmm.
When you took those four angles and you just cut them off and kind of
yeah.
slid them right on top of the other ones, it was like, well, which one lines up with the other one?
Right.
It's the same idea. Which part of the triangle is exactly the same as the other triangle we're looking at? Which side is the same on this triangle as it is on that triangle? So it's the same idea as corresponding angles on the transversals. Now we're just looking at it through triangles.
Yeah, I've never made that comparison. I don't know why.
Yep.
So as long as you caught that concept of corresponding angles with the parallel lines, those are the ones that slide and land on top of each other. Same thing here.
Yeah, it's not that much of a
We
stretch.
could have angles or sides,
Yep.
landing
Yep.
on top of each other. So, yeah, it's a good jump. A congruent statement. Now, this is basically saying that the two triangles are congruent to each other.
Right.
But it doesn't matter how you label a triangle in the first part of the statement, saying triangle ABC or triangle BCA or triangle CBA or whatever, however you put the first one. But the second one then is critical how that order is. It has to be which piece lands on the piece that is labeled in the other one, the order of the other one. So the congruent statement is critical, and we'll go over this over and over again,
Right.
as we go through this chapter, right? So which vertices and segments are congruent based on order? Order is what's important there.
So we want to name the corresponding parts here. So here's a first look, guys, at a congruence statement.
Yeah.
So right here it says that triangle ABC is congruent to triangle DEF. And so that congruent statement says that A has to match up, has to be corresponding with D, B has to be corresponding with E, and C has to be corresponding to F. So if I took this triangle and I dropped this triangle right on top, actually, Kevin, you'll have to do it with your left hand there. If Mr. Scritchfield puts his left hand over my right hand, see how our thumbs line up and then our index fingers and so on and so forth? That's basically what that's saying. I couldn't go like this because now my thumb's not lining up with his thumb and it's not right anymore. So when you hear congruent or corresponding parts, it's kind of like, laying the hands on top of one another, and they have to be the thumb to the thumb and things like that. So
Yeah. So that statement means angle A measures the same as angle D.
there you go.
So maybe they're both 30 degrees or whatever.
Right.
Angle B has to measure the same as angle E, and angle C has to measure the same as angle F.
Right.
They each individually have to be congruent to each other in angles.
So if you had to list all the corresponding parts of congruent triangles, there would be 3 pairs of congruent angles and 3 pairs of congruent sides or segments. Now the side thing is somewhat tricky at first because it's easy to see, okay, so if I break this up into segments, AB is the same as DE and BC is the same as EF, but that's only 2 out of the 3 sides. So the third side is the front to the last, so AC is congruent to DF, and I think sometimes students struggle with making that third side connection without a visual.
Right.
So maybe a visual comes in here.
Actually, they just pick certain ones.
Okay.
So you do need to know that all 6 of those things are true. 3 angles are congruent, 3 sides are congruent, but they're picking particular examples here of asking you which ones would be true.
So based on that congruent statement up there, guys, of triangle ABC is congruent to triangle DEF, basically what you want to do is say, okay, segment BC. Well, if I look at triangle ABC and then I slide over to triangle DEF, well, B is the same as E and C is the same as F, so I'm going to be congruent to side EF, okay, or segment EF. There it is. All right. Now, angle D is the first angle on the triangle on the right, so I just slide over to the other triangle ABC, and A is the first letter listed or angle listed, and so angle D is congruent to angle A. It's just basic matching, guys. I mean, it's not too difficult here. And then here's that jump one I was talking about. So A to C would be the same as D and F. Okay, A is in the same place as D, C is in the same place as F, so it's just DF.
Right. And if we could draw on here, it'd be, the first letter to the third letter in the ABC, first letter to the third letter in the DEF, and those are the ones that line up here.
Yep.
So you need to be able to come up with all 6. This one was just asking you for specific ones out of those 6.
Yep.
But we'll cut this down soon to where we don't have to do all 6 of them. But that's the definition of congruent triangles.
Right.
Is that all 6 pieces that line up are congruent. So here's looking at it in turn. We did it in the last slide where we just have a statement. Now we're looking at an actual 2 triangles that line up with each other. And so now they didn't do it, extremely easy here, to where the other triangle is flipped over and looks exactly like the other one. There's a flip going on here at least, and so you just need to be careful.
But you can just use some common sense, really. I mean, angle T looks pretty darn small, and so does angle J.
Yep.
So when you say your things, match those up. Angle N and angle B both look like they're 90.
Right angles.
Yeah, I mean, so you just use some common sense here, guys. Mr. Scritchfield and I are really going to try to get you guys to use some common sense here on a lot of this, and you can make some kind of, deductions or out of some of this, or inductions based on some patterns that you understand, and then we can deduce it later.
Right. Right.
Anyways.
Now this diagram has the hash marks that we've been using, so you need to use those still, and they probably come into play a little bit more now because we're talking about different segments in the same diagram that are congruent. So we could have their single hash mark ones are congruent, double hash mark ones are congruent, and the triple hash marks ones are congruent. And so you need to see which ones line up here. And so, like Mr. Bedell was just saying, so if the triangle NUT, triangle nut here, is the N is first, what angle in the other triangle would land on the angle N over in the first triangle? Well, it would be angle B. Because if you just flip this triangle over and land on that one, angle B would land on angle N. U is up there at the top, and so again, when you flip that triangle over, O is going to come over here and land on U. And then the J just kind of flips over quickly right onto T. And so the order would be B landing on N, O landing on U, J landing on T. So it would be BOJ is the correct order of that congruent statement based on this diagram.
I mean, it really is a matter of just being able to visually move things around in your head. Yeah, I mean, if you can do that, I mean, it's pretty darn easy. Even when the triangles look very similar as far as angles and stuff, like there's some similar angles within them, you just got to think about it a little bit and mentally be able to move things around.
Right. Sometimes we got to slide them or spin them around. Sometimes you got to flip them over like this one.
Yeah.
So now they're asking for out of that statement or out of the diagram, maybe it'd be easier out of the diagram, like the last slide, to come up with very specific ones of these. So if you look at the triangle on the right, because it has JB in it, so JB is that bottom piece. Well, what's the bottom piece in this triangle? NT. JB has 2 hash marks. On this triangle, NT has 2 hash marks.
But Mr. Scritchfield, how come I have they want to know JB twice right there?
Well, we need to notice the difference in the symbols here, two symbols actually.
Yeah.
One of them is the fact that its segment JB is congruent to what segment, and that one we would just name as TN. But this one, the bottom one, doesn't have a segment over the top, and it's equals. And so remember, when there's no notation, when it's not a ray or a segment or a line or a whatever, that means the actual length of it. Well, how are we going to figure that out, though?
Well, we just use what I did previously, and if I know TN is the same as JB, and I know that TN is 15, well then JB's got to also be 15.
All right, we got to notice that NT is set aside there as being 15, labeled as 15.
Yep.
And so if they're congruent, then JB has to be 15 centimeters as well.
And this to me, this really just kind of reminds you guys again of those two planes of geometry. There's the visual plane,
Right.
and then there's that mathematical plane, and you got to recognize in the semantics whether they're talking visual or whether they're talking math.
Yep.
You know, and so it's really, really important because they're going to do that a lot, guys.
Yeah. And we really could do the same thing here.
Yep.
You know, it's asking for what angle U is congruent to.
Right.
Well, again, when you flip the 1 over on top of it, it'd be angle O, but they could ask us what the measure of angle O is.
Right, and they do right there. And for math.
There you go. Okay, sorry, I was looking for a measure of angle U down there, and
There you
there's
go.
the measure of angle O.
But that's okay because it just kind of leads into the same thing. If the measurement of U is 56, well then the measurement of O must also be 56 because in the previous statement we said that measurement of U is congruent to measurement of O. And it's this idea again of what can I conclude?
Right.
I know that U is congruent to O, so therefore if U is 56, I know that O is also 56. It's that law of detachment.
Mm-hmm.
You know.
Right. Yep. Measure of angle T. Now, how are we going to do that? We're going to have to do several steps.
Yeah.
Mr. Bedell, what do you got?
Well, in the previous section, we learned that all triangles add up to 180 degrees.
Right.
And so if I know that this angle B is 90, then I know angle N is 90, which means I only have 90 degrees left to split between angle U and angle T.
Right.
And if I know that angle U is 56, well then all I got to do is go 90 minus 56, and that gives me 34. And so if the measurement of angle J is 34, the measurement of angle 2 has also got to be 34, however you want to look at it, but T has got to be 34 degrees.
Yep.
Okay, hey, things are 180 degrees in those triangles, guys. Don't forget that.
Yeah. Yeah. Now, this is kind of a different question
Oh, yeah.
because it's a triangle.
Yep,
And so all they did was just mix up the letters.
that's right.
And so, but this makes the point that order is critical.
Yes, that's right.
And so it's not triangle BOJ anymore, it's triangle JOB. And so if we just reversed the order of the JOB to BOJ in the original statement, we're just going to have to reverse the order of the other one.
Yep,
Angle J would land on angle T, angle O would land on angle U, angle B would land on angle N, and so this would just turn that around and make it triangle TUN.
yep. And if you do really, really well in geometry, guys, you'll get a ton of jobs.
There you go. We should end right there, but
Yes, we're
I think
nerds.
we have another slide. So. All right, new theorem here.
Yep,
And this one's critical because
Yeah.
we use this quite a bit, but
Yeah.
it's very logical
makes sense to me.
from
Common
the
sense.
last section.
Yeah,
Because of the 180 degrees.
totally.
Right. And so what this says is that if two angles of one triangle are congruent to two angles of the other ones have to be congruent.
That's right.
Let's throw in some numbers here. So the top one has a single hash mark on it. Let's say that's 100 degrees. Both of them, because they're congruent.
Right.
Angle A and angle D, they are congruent to each other. Let's say that's let's do it 50. Let's say that's a 50-degree angle. So altogether in one triangle we have 150. So what does that make angle C? Has to be 30. Well, the other triangle is the same thing.
Yep.
It's got 150 in it also, and so subtract from 180, that has to be a 30 also. So this is just going to go around all the time. When you have two angles in a triangle congruent to two angles in another triangle, the third one has to be congruent also.
It's kind of a weird transitive property.
It is a little bit, yeah, because it kind of includes some subtraction in there and so on.
Yeah.
But this allows us to do some of our shortcuts for
Yeah.
proving triangles congruent.
For sure. I mean, it's just to me, shorthand is if you know 2, you know 3.
Right. Yeah. Yep.
You know, so
Yeah, it is. Yeah, it's kind of a long.
yeah, because I
not
know
really
this and then I know
transitive, but-
this, then I can say this.
Yep.
You know, I mean, it's kind of transitive to me.
Yeah.
Sort of, in a weird
Sort
way.
of, yeah.
Because you're not substituting anything out, but
No, and you don't have a middleman necessarily,
right.
but
It's
Yeah.
just kind of it's that if and then kind of
Right.
an idea.
Right.
So,
Yeah.
anyways,
so that should make sense to you.
yeah,
Just based on measurements there.
Best
Okay.
part of triangles is they're always 180
180,
degrees,
that
man.
makes a lot of things easy to
just
solve.
cuts out all the guesswork.
Yep. Last slide here, guys.
Yay.
Properties of so this was chapter 1, wasn't it? Reflexive, symmetric,
Oh,
and
yeah.
transitive? I
Yep.
think so.
Here
So
we
we
go.
gotta
Hey,
go
my
back to
friend
chapter 1.
transitive. Yep.
Yeah. We just had this on the chapter 3 test too.
Yep.
And so all we're saying is that those properties also apply. We did them with segments and angles before, but they also apply to triangles.
You must know reflexive.
Yes, we're going to use that. This chapter especially, we're going to use reflexive over and over and over.
Yep.
So reflexive was what?
If you see yourself in the mirror, you look in the mirror, you see yourself. So it's reflexive is if I got triangle ABC on one side, I know that triangle ABC is congruent to triangle ABC.
Yeah, anything that's congruent to itself is
Yep.
reflexive.
Yep.
Okay.
Kind of the identity idea.
Yeah, yeah.
And then go ahead.
Good. Well, the symmetric, it just flips it though.
Yeah.
It's kind of like that last one that we just did, the job and the ton and the
Yeah.
whatever.
Yep.
It just flips the order around. So if ABC is congruent to DEF, we just flip that around, right? So DEF is congruent to ABC. We didn't reorder the triangles, I guess, like that other one, but still.
It's kind of like saying this hand's the same as this hand. If I switch my hands, they're still the same.
Yep.
It's a two-dimensional object. They're still the same, guys. Doesn't hurt anything.
Mm-hmm.
Okay. And when we look at like rotations and reflections and stuff like that, that's kind of the idea of you can flip a triangle over or move it around, and it's still the same triangle.
Yeah. No, the
Yeah.
angles didn't get moved.
That's right.
The segments didn't get longer. We didn't squeeze out one side longer than the other or anything. It stayed the same triangle.
Yep. And then transitive, my favorite is, hey, there might be more than two triangles out there that are the same. So if triangle ABC is the same as triangle DEF and triangle DEF is the same as triangle GHI, well, we cut out the middleman and triangle ABC is also the same as triangle GHI.
Yep.
So, I mean, to me, what I love about geometry is it constantly builds upon itself.
Yep. Yep. We're just building shapes here.
Yeah.
From triangles and sides going up to triangles and segments. Angles and segments up to triangles.
Yep.
So, okay, guys.
All right, guys.
We're going to practice this a lot.
Ta-ta.
So we'll see you in class.